Hello, calculus fans. All right, let's try to evaluate the integral from 3 to 5 of dx over square root of x squared plus 10x. Now this doesn't fit in very well with our inverse trig substitutions because we need to have something squared minus something squared or something squared plus something squared. But the problem is 10x is not really a square. All right, so we're going to complete the square. This is one of our techniques from algebra and pre-calculus. So remember how this goes. To find out what we have to put in, we're going to take the coefficient on the x term, that's 10, divide by 2, and then square whatever we get. So in this case, we're going to take the 10, divide by 2, square that whole thing, and we get 25. So that's what we're going to have to put in there to make it into a perfect square. So we take the x squared plus 10x, and now we're going to add 25. Here's the thing about adding 25. If you're going to add 25, you also have to subtract 25. Well, you can't just add 25 any place you feel like it. Listen, if I could just add 25 any place I felt like it, I would just add 25 to my bank account and keep doing that. Well, I'd be retired pretty soon. So anytime you want to add something, you have to subtract to compensate. Okay, so that turns into x plus 5 quantity squared minus 25. So now let's look at what our integral turns into. We change the radicand from x squared plus 10x into x plus 5 squared minus 25. You know, I've used this word, radicand. The radicand is the thing inside the square root. This is kind of a useful word. We also have a word like integrand, which tells us that's the thing that we're integrating. Okay, so I'd like to be able to use the word radicand. Everybody should know what that means. Okay, so let's worry about evaluating this integral. So now we're ready to make an inverse trig substitution because now our radicand is in the shape of something squared minus something squared. All right, so that tells us to make an inverse secant substitution because it's a variable squared minus a number squared. Now in this case the variable is x plus 5. That's okay. Works out just fine. So our substitution is to let theta be equal to arcsecant of x plus 5 over 5. And now this also tells us that secant theta is equal to x plus 5 over 5. Well, let's draw the triangle associated with this. So once we know that secant theta is x plus 5 over 5, that enables us to fill in the two sides here, and then the third side gets worked out using the Pythagorean theorem, just like we had before. Now you should go ahead and work that out for yourself to make sure that you see why we get this. Based on our triangle now, 5 tangent theta is equal to the square root of x plus 5 squared minus 25. We also know that 5 secant theta is equal to x plus 5. And by taking a derivative, now we get 5 secant theta tangent theta d theta is equal to dx. We have one more thing we need to do before we're ready to evaluate the integral, and that is we're going to change the limits of integration. So if we plug in 3 into our substitution, we get arcsecant of 3 plus 5 over 5, which is arcsecant of 8/5. If we plug in 5, we get arcsecant of 2. Now this is something that we can actually calculate exactly. Arcsecant of 2 is pi over 3 because the secant of pi over 3 is 2. You should work out the trigonometry on that and make sure you know how we got pi over 3 there. Unfortunately, there's not much we're going to be able to do with the arcsecant of 8/5. We'll have to leave it like that. Later on, I'll show you how we can work out our final answer to not have things like arcsecant of 8/5 hanging around. Okay, but let's carry on now with the integral. We're ready to change the integral from x into theta. All right, so we should get this. You go back and look at each piece that we have and how it got transformed, we should get something that looks like this. Arcsecant of 8/5 to pi over 3. We have 5 secant theta tangent theta over 5 tangent theta and then d theta. So each piece got transformed. The dx, you should be able to see that the dx got transformed into this, and that whole gigantic denominator got transformed into this. And the good news is a whole bunch of stuff cancels, right? The tangents cancel, the 5 cancels, and look, the only thing that's left is that secant theta. So here's our integral. Now, antiderivative of secant theta is something that you should know. If you don't have that committed to memory, you should work on that. Put that on your list of things that you need to compute an antiderivative of, have committed to memory. All right, so an antiderivative of secant theta is natural log of absolute value of secant theta plus tangent theta. And we're going to evaluate this from arcsecant of 8/5 to pi over 3. Okay, so if we plug everything in, then we end up with this gigantic mess. Natural log of secant pi over 3 plus tangent pi over 3 minus secant of arcsecant of 8/5 plus tangent of arcsecant of 8/5. Now I've dropped all the absolute values because it's going to turn out that all these things on the inside are positive. Now some of this stuff is straightforward to compute. Secant of pi over 3 and tangent of pi over 3, we should be able to compute those just from our knowledge of the unit circle. Meanwhile, secant of arcsecant of 8/5, well, that's just going to turn into 8/5. Because remember, secant and arcsecant are inverses of each other. Okay, secant of pi over 3 is 2. Tangent of pi over 3 is root 3. Make sure you can work those out. All right, so we're going to get this. Log of 2 plus root 3 minus log of 8/5 plus tangent of arcsecant of 8/5. So really, what it boils down to is we need to figure out what tangent of arcsecant of 8/5 is. And this can be calculated, so we don't want to leave this lurking around. This does not fall under the no simplification policy. So that's what we're going to work out now. We're going to simplify tangent of arcsecant of 8/5. And what we'll do is we'll set up a triangle to help us out. So the angle in question is arcsecant of 8/5. All right, we're doing the tangent of some angle we don't know, arcsecant of 8/5. Let's draw a triangle. So secant of phi is equal to 8/5. All right, here's the triangle that goes with that. If secant of phi is equal to 8/5, then we should have the hypotenuse is 8 and the adjacent side is 5. As usual, we'll use the Pythagorean theorem to work out what the missing side is. So that missing side is w. Let's just call it w. And the Pythagorean theorem tells us that 5 squared plus w squared is equal to 8 squared. All right, so that gives us w. W is going to be square root of 39. Okay, so if we go back to our picture, now we know what tangent of this is. Tangent of phi. So based on the picture, we can just say opposite over adjacent. So that's w over 5. We calculated w was square root of 39. So that's what tangent of arcsecant of 8/5 will be, root 39 over 5. All right, now we can give our final answer, should look like this, and then we can replace the tangent of arcsecant of 8/5 with something a little bit more palatable. And that's it. That's going to be our final answer. Nothing else left to do. Okay, that's all for now.